as the name says, it's the application of chemical principles to the research about life functions and life processes. First of all, I'm not a biochemist, so I studied as a physicist and ended up working in an institute for biochemistry, which put me at an advantage and at a disadvantage. Advantage because I knew more about physics than the average biochemist, and disadvantage, I know nothing about biochemistry, so I had to learn everything sort of the hard way. One was my mentor during my master's thesis, who was a professor of physics, and he emphasized to students the importance of physics in life, researching life processes, and that had just begun at the time, or there were, of course, important sort of leaders in the field, like Erwin Schrödinger, What is Life? And I mean, it's a fascinating book still today, and so it's about these physicists who became interested in life processes, and Max Delbrück, of course, was a very prominent example. And then, my mentor during the doctoral thesis, Robert Huber, was very important, of course, and I learned the trade from him, or while working in his group, and so these were probably the most important ones. Yeah, of course, there were two, and one was a 1984 paper in Journal of Molecular Biology, which described the cofactor structures in the reaction center, and it was not yet possible to interpret the whole electron density for the whole protein. Mainly because we didn't have an amino acid sequence at the time, and also it was at that time a huge amount of work to build the model, and so we decided to come out with sort of the main points, and then the year later was a paper in Nature about the complete structure. Well, without fundamental research, there is nothing to apply. So I think that there's a danger of sort of overshooting. It is clear that we now know a lot of things about life, about the human body, about possible interventions in medical conditions, and it is certainly justified to invest in research in these directions. But we cannot pretend that we know everything. Quite on the contrary. And so abandoning basic research would be a big mistake. There were several people. The one I remember most clearly was the one in high school. He was a teacher in mathematics and physics, and he had a way of talking about these subjects that was just fascinating. So I was already infected with the idea maybe I can become a scientist, and I was very much inclined to study astronomy, and I think he contributed to the sort of a little bit of a change in mind, trying to be more general, and then expecting that later on I would still have the possibility to focus on astronomy, which I didn't do, of course. I have very little opinion on that. It would have to be done at a level of that I'm not used to. I don't have children, so I was not under the necessity to find the right sort of words for children at that age. I had some nephews, but they so how do I say, you cannot avoid talking about scientific facts to children. You cannot avoid that, but whether one should sort of start indoctrinating them at that age, I don't know. It could backfire. I mean, they could get fed up and hate the subject, and so it's probably better if they at least believe that they discovered this by themselves. I must admit, I don't even know what the age index is. And I think it maybe refers to publications, yes, records. And I think that is a vast overemphasis on this. I mean, I can see that certain administrations, they want to have sort of what they think would be objective measures of the output of a scientist. But I think this gives journal editors a power that they don't deserve. And I can only mention the very first paper about the subject for which we got the Nobel Prize. That was published by my friend Hartmut Michel, and he sent it to Nature, and they were not interested. So that's the reason why we sent our first paper not to Nature, even though they expressed interest. but I mean, if something is really important, it will make its way to the general knowledge, almost no matter where it appears. Yeah. Yeah, I have never thought about this very carefully, and it is clear that some people, some scientists have a long legacy of excellent students, and others have less. And I belong to the second category. I was never a sort of, or it required a particular type of student for them to be able to work with me. Yes, and so. I don't know what the purpose of this would be. Whether one can construct this, so the ideal mentor, and then teach mentoring too. I mean, we are all sort of, we learn scientific techniques and learn about the results of others and so on, and when we get into the position of leading a group and having students and so on, that we all learn on the job. So some people have a natural gift, others don't. It is important to make clear the difference between scientific thinking and, let's say, ideological thinking. And scientific thinking, in my view, is characterized by a lack of certainty. There is no certainty. There's only high probability and low probability. And I know that this is very, very hard to bring close to people who are not thinking about that all the time. And so, but it would be worthwhile for public figures to incorporate that a little bit better into their behavior, in the way they talk. But what we observe, of course, is the opposite. I mean, they want to sound very certain, and even if they have no idea what will happen, they are absolutely sure that. And so it's a very, very tough process to introduce more scientific thinking into politics. Well, it was a very enlightening and interesting meeting, because I think I've never seen a meeting, or it's been a very, very long time since I saw a meeting where there are so many young people, especially ladies, young ladies. I mean, the mixture is apparently sort of in favor of females, and if this is the future of science, it is wonderful.